Hello everyone, this is Nidhi BG from Department of Computer Science Engineering, PESITEM, Shimoga. Today I'm going to discuss about the topic Introduction to Semiconductor RAM Memories from Module 5 of Computer Organization. First, let us know what semiconductor memory is. Semiconductor memory is used in any electronics assembly that uses computer processing technology. Semiconductor memory is the essential electronics component which is needed for any computer-based PCB assembly. The contents we are going to discuss today are RAM, cache memory, virtual memory, and classification of RAM. Let us know what RAM is. RAM is random access memory. It is the form of computer memory that can be read and changed in any order, typically used to store working data and machine code. A random access memory device allows data items to be read or written in almost the same amount of time irrespective of the physical location of the data inside the memory. In contrast with other direct access data storage media such as hard disks, CDs, DVDs, the time required to read and write data items varies significantly depending on their physical locations on the recording medium. The memory organization of RAM is like this. There is RAM memory which has three areas. In the area 1 there is persistent information. In the area 2 there is non-FIFO allocation information. In area 3 there is FIFO allocation information. FIFO is first input first output, which has the computer instructions class variables, and non-FIFO allocation information has instant variables, and area 3 FIFO allocation information has local variables and parameter variables. The area between area 2 and area 3 is not yet used. This is the memory organization of RAM which gives input to computers. Next is the topic cache memory. Cache memory is very special, very high speed memory. It is used to speed up and synchronizing with high speed CPU. Cache memory is costlier than main memory or disk memory but economical than CPU registers. Cache memory is an extremely fast memory type that acts as a buffer between RAM and the CPU. It holds frequently requested data and instructions so that immediately available to the CPU when needed. Cache memory is used to reduce the average time to access data from main memory. The cache is a smaller and faster memory which stores copies of the data from frequently used main memory locations. The organization of cache memory is like this. Cache memory has memory address from the processor. It has main memory accessed if address is not in the cache, which moves to the main memory. Then there are two subdivisions called as address and data space. If the address is found, then it directly moves to the data address location. If the address is not found, then it moves to the cache, which moves to the main memory. There is a comparison between all storage addresses simultaneously in the cache memory. Next, let us move to the topic of virtual memory, where virtual memory is the address which is generated by the process and is referred to as virtual or logical address. The virtual address space is mapped onto the physical memory where the data are actually stored. The mapping function is implemented by MMU, which is known as Memory Management Unit. Only the active portion of the address space is mapped into location in the physical memory. The remaining virtual address are mapped onto the bulk storage device such as magnetic disk. As the active portion of the virtual address space changes during the program execution, the memory changes the mapping function and transfers the data between disk and the memory. During every memory cycle, MMU determines whether the addressed page is in the memory. If the page is in the memory, then the proper word is accessed and execution proceeds. Otherwise, a page containing desired word is transferred from disk to memory. This is the organization of virtual memory, which is connected to the mapper by CPU, which has logical page and physical figure in the key and value of page table. Every page has a frame which moves to the main memory, and a combination of all page frames are present in the main memory, which has the mapper in the between. The page frame along with the X data, which is also known as cache memory, moves to the main memory to have the page table. Let us know what is the classification of RAM. Random access memory can be classified as follows: static RAM and dynamic RAM. Static RAM is called as SRAM and dynamic RAM is known as DRAM, which can be further classified into synchronous and asynchronous RAM. Static RAM. The word static itself indicates the main memory retains its contents as long as power is being supplied. However, the data is lost when the power gets down due to volatile nature. There is an extra space in the matrix, hence SRAM uses more chips than DRAM for the same amount of storage space, making the manufacturing cost higher. SRAM is thus used as cache memory and has very fast access. Characteristics of SRAM: long life, no need to refresh, faster, used as cache memory, larger size, expensive and high power consumption. These are the characteristics of SRAM. Let us know what dynamic RAM, that is DRAM, is. DRAM, unlike SRAM, is continually refreshed in order to maintain the data. This is done by placing the memory on the refresh circuit that rewrites the data several hundred times per second. DRAM is also used for most system memory as it is cheap and small. Characteristics of DRAM stays like this. It is short data lifetime. It is not needed to be refreshed continuously. It is slower as compared to SRAM. It is used as RAM. It is smaller in size. It is less expensive and it uses less power consumption. Although we have read about SRAM and DRAM separately, we cannot confirm with all the differences between SRAM and DRAM. Let us know the differences between the SRAM and DRAM. The full form of SRAM, along with the parameters, is the full form of SRAM along with the parameter full form is static random access memory, and DRAM is dynamic random access memory. On the parameter of read and write speed, SRAM is faster when compared to DRAM. Next comes the storage component, where SRAM is used as transistor to store single bit of information and DRAM is used to separate capacitor to store each bit of data. The price of the SRAM is expensive than DRAM, whereas DRAM is economically smaller than SRAM. Next comes to know about the power consumption. SRAM uses more power when compared to DRAM, and DRAM uses less power compared to SRAM. Refreshing unit as the parameter. SRAM, there is no need to refresh for maintaining the data, whereas in DRAM, it has to be refreshed thousands of times every second. Next is about the parameter in which SRAM or DRAM is used in. SRAM is used in cache memory and DRAM is used in main memory. Next is about the internal structure of SRAM and DRAM. SRAM is complex structure, whereas DRAM has simpler than SRAM. Next is about the density. SRAM is less dense when compared to DRAM and DRAM is highly dense. Next is about the storage per bit. SRAM can store many bits per chip. That is, one chip can store many bits which has many information, whereas DRAM cannot store many bits per chip. This is the basic difference between SRAM and DRAM, and when went deeper, let us learn that in the other chapters. Thank you.